A system consists of two objects having masses m1 and m2, shown in the diagram on the left here, where m1 is smaller than m2. The objects are connected by a massless string hung over a pulley as shown and then released. When the object of mass m2 has descended a distance of h, how does the potential energy of this system change? How is the potential energy of the system decreased? By how much? So quickly adding on to our diagram here, what we're asked is we have this setup and then it's released. And we are wondering, after this mass descends, goes down a distance of h, the potential energy of the system decreases by how much? So if m2 goes down a distance of h, since it's connected to m1, then m1 also goes up a distance of h because they're attached. Okay. Now, thinking about the potential energy EP before the masses are released, not an equal sign, and comparing it to the potential energy after the masses are released, which one is bigger? Well, since mass 2 is bigger than mass 1, and mass 2 has gone down, its height has gone down, that means that the potential energy after must be less. Okay, going back to our equation that describes potential energy, if the height of the heaviest of the two objects has gone down, then the overall potential energy must have gone down, which means the energy before was greater. So how does this help us find how much the energy was decreased by? Well, first let's write out just an equation to describe the potential energy afterwards for these two masses. So the potential energy of mass 1 is equal to mass m1 times g times the height. So we're trying to find the potential energy afterwards, okay? And the potential energy for mass 2 after it's released at a height h is m2 times g times h. Okay, so we're looking at the potential energies at these new points. Now, how much has it decreased by? Well, obviously this potential energy value must be positive. We're finding out how much energy has it decreased by. In other words, what positive number has it gone down by? And to create a positive number using these two potential energies, we need to make sure that we subtract EP2 from EP, or EP1 from EP2. Since this number is going to be bigger because it has a larger mass, we need to make sure that mass 1 is subtracted from mass 2. So if we say EP2 minus EP1, so we're finding the difference in potential energy of these two masses. EP2 is m2g times h minus m1gh. We can factor a gh out from both sides, and we have m2 minus m1. And that right there is how much the potential energy of the system is decreased by, right? The difference in these masses gives us some positive number, times the new height, times the gravitational constant, tells us how much the potential energy has decreased by. It's going down. So this is delta E, the change in potential energy, and that's equal to this one here.